I've collected some data from a student in our class, and I've put their data in this table. And what you can see is for each sample of fish that they've caught, we have an estimated population based on our doing the equivalent ratios. So for those of you who had done the assignment last week, you understand kind of where this data is coming from. If you didn't do the assignment last week, that's okay. We'll just focus on how we construct the box plot from this data. So if I want to construct a box plot from the estimated population data, does anyone have an idea of what I should do first, or what steps I need to go through in order to construct that box plot?
You should find the average of all your data.
You think we should find the average
of your data first?
To make a box plot?
To find, yeah, because you need a mean to construct a box plot.
Is that true that we need a mean to construct a box plot?
Oh, yeah.
Is the mean in the box plot? I'm getting a lot of no's coming out.
No.
So I'm seeing that we should be finding the median instead. Ziha, what do you think?
I looked at the home page. That's where I got finding the average for.
That's true. We might find the average to get some other information about the measures of central tendency, but right now we're looking to construct a box plot. So I'm wondering what steps we need to take in order to construct the box plot. So what should I do first? Median first. Okay, how do I find the median? I keep seeing people type in median first. How do I find the median? Who wants to share how I organize the number? What does he mean by, put them in numerical order? Okay, so let's put the numbers in numerical order. Okay. Now we have our ordered set. So, and you guys said you want me to find the median. How do I find the median of this ordered set? So Lori's saying cross up the numbers from each side and continue this until we get to the middle. What just happened? I see then divide. What do you mean then divide? Add the middle? I'm not really sure. What do you mean by add the middle? You guys can also turn your mics on if that's helpful. 275. Okay, 275 and 283. So these two numbers were in the middle. Find the average of the two middle numbers. Okay. So let's see. 275. Okay, great. We found the median. Now what? What should we do next if we want to construct the box plot? Find the maximum minimum? Yeah, we could do that. Let's find the maximum minimum. What's the maximum? Largest number, so that's 575. Minimum is 185. Okay, is there any other information that we need in order to construct the box plot? Oh, lower and upper quartiles, okay. How do I find the lower and upper quartiles? Maybe we'll do the lower first. Does anyone have an idea of what the lower quartile is? 205. How did he get 205? How did Jerry get 205 and Lori and Martin? Separate the two halves. Yeah, so we're going to look at the first half of the data up to the median. And then we're going to find the number in the first half of the data. So that's 205. And now let's do the same thing for the upper quartile. We look at the upper half of the data, and we look for the number in the middle of the upper half of the data. I'm seeing people say 315.
315.
Great. Now what do we do?
Lower, enter the IQR.
All right, we can find the IQR. The IQR is
110.
110. Okay, great. Start to graph plot. Okay, so let's make a number line. How should I construct this number line?
Your maximum should be on the left side of the number line.
The maximum?
I mean, your minimum. Your minimum.
Oh, okay. So let's put like 180 maybe here, 180. And now, what do you guys think our scale should be? Five. Christine, if it's 5, I have to go from 180 all the way up to almost 600. Do you think that'll fit on my paper here? So what do you guys think we should go by? 10? Anyone? Any other suggestions? Do you think it's fun to count by 15s, Albert? Anaya, 5. Anaya, again, if it's 5 and I start counting by 5, do you think I'll be able to fit all the way up to 575?
No.
Right, we're going to run out of space. So let's, I guess, I see a lot of people writing 20. We could do 20. 180, 200, 220, 240, 260, 280, 300, 320, 340, 360, 380, 400. Notice I don't have to put numbers at every single tally. Great. Okay. Now what? Yeah, you know, it's not necessary to fill in every tally mark because they become very overwhelming with the space. So maybe we just fill in every other one or some of them. Put the minimum. Okay, we'll put the minimum down. The minimum was 185. Put the maximum, 575. What else do we need in our box plot? Put the median. Median is 279. We have our lower quartile, which is 205. We have our upper quartile, which is 315. Now we can construct our box. Okay. Now what? What questions do we have? I want to hear some questions from you guys about this plot. What are we noticing? Maybe some of you can turn your mics on and share some ideas of what you're noticing. It's mostly what? What was that?
On the left side.
Mostly on the left side, okay. Anyone else? Let's add in some details. What else do we notice about it?
I would say it's more spread out on the right side.
Okay, good. It's more spread out on the right side, so we're seeing some like variability here. Anything else you want to share that you think is insightful or something that might be interesting to talk about? What do you guys think about this, the 575? Why do we think, yeah, the first 25% is kind of clustered. Good, Albert. The first 25% is clustered. Why do we think the 575 is so far away from the rest of the data? What happened? Like, do you guys think there's 575 fish in the pond? Do you think that's a good estimation for the number of fish in the pool? So then why did that come up in our experiment? If we look at the 6 experiments, why is one in the piece of data so far away in the sample size? Albert, what do you mean by the sample size? It's a small sample size. Christine, why is that important to think about, that this is a small sample size? I just missed that comment. Can you type it again? I'm sorry, Christine. I couldn't read it fast enough. What thing, Martin? Why are small sample sizes less accurate? That's a good idea. Why do we think small sample sizes are less? I'm going to write that down here. Small sample sizes tend to be less accurate. That was from Christine. The more the better. So larger sample size, the more accurate our data becomes. Can someone use the box plot as a way to back up that claim that a large sample size gives us a better estimation of the number of fish? Who can use the box plot and the data to justify that claim that a large sample size tends to be more accurate? Large sample size are clustered together. Good. That's 1 point. Who wants to add on to that or come up with another way to justify that the large sample sizes are more accurate as an estimation for the number of fish in the pond? What's the connection between our larger sample size and the box plot? It represents more of the population. Lori, that's absolutely right. A larger sample will represent more of the population. But let's try to connect the data to the box plot. What connections can we make between the data and the box plot to support our claim that larger sample sizes are more accurate or better represent the population? What was our estimation for the largest sample that we took? $275. 275 fish is our estimation using the largest sample size. Now look at our box plot. Where does 275 fall in our box plot? Yeah, almost right in the middle, right? That's our largest sample size, and it's falling almost directly in the middle of our box plot. Yeah, so why do you guys think that's happened? Martin wants to know why we think that happened. That the largest sample size, which makes it inaccurate. See how you think this is inaccurate, the 275? You don't think that's a good guess for the number of fish in the tank? Yeah, it's Alvin. It's pretty accurate because it's like right in the middle of our data set. Jerry, why are you confused? Can you maybe turn on your mic, guys? It might be easier if your mic was on and you could talk. Let's also find the average. Zihao had mentioned discussing the average. Did anyone calculate the average yet? Can we have someone do that quickly? Calculate the average of those 6 data points. Let's see who can grab a calculator and calculate the average for us. 275.5. Do we agree with Christine? 275.5 for the average of these 6 data points. You guys tried it on your own? I did not get 275.5, so I'm not sure how you guys are getting 275.5 as the average of those 6 numbers. Yeah, Zihao, you're correct. So I'm wondering where the 275.5 came from. It's 306 1/3. Remember, there are 6 data points. So if we had to use all this information together to make a final estimation for the number of fish, maybe they did the 279. Yeah, the 279 is not included. That's the median. That wasn't part of our original data set. What would you guys estimate the number of the fish in the pond to be? What would be your final estimation for the number of fish in the pond if we had to use all this information to estimate the number of fish in the pond? I want to see some estimates typed in. You think that's the number of fish in the pond? 306 1/3 repeated. What's our estimation? Okay, Dre, what do you think our estimation is for the number of fish in the pond? What's our best guess? Using all 306? Use the box plot, use the data, use the average, right? We can use all these things to help us figure out how our best estimate for the number of fish in the pond. Around 275. Not sure. Maybe 300. Ziha, why 300? What's making you go up to 300?
I think it's 300 because I used the data plot because if we put 300 is like in between the 279 and the 315. So
Zihow's thinking. You see how you're thinking somewhere in here,
yeah, somewhere over there.
and maybe also you're looking at the average.
Yeah.
Okay. Any other thoughts? So basically, this is what you're going to do on your own in a few minutes with your own data. So I shared that sheet with you.